All right, hello guys. So this video is actually going to be for week 8, and the topic that I'll be talking about is actually reasoning models. Well, to get started, my name is Adrian Flores, and this is mainly for my class CS 4540, also known as Intelligent Agents in Learning Environments. For this video, I'm not really gonna add a recap since it is something I would say a new topic, so the previous videos don't really correspond to this. So yeah, let me get started. What are reasoning models? If you guys haven't really heard of it, it's pretty much just a artificial intelligence system that is pretty much created just to have human thought processes and make decisions or solve problems like a human, based on the observations or data that is given. So pretty much just make it so that the model is actually very similar to a human when thinking or responding to a certain problem. It could either be easy or complex. But the thing with this is that there is some issues whether even if it's like an easy question that it is being asked or some straightforward data, when it comes to the output, it might give just some very complicated or complex outputs, which would just pretty much just not be necessary for the simple question that it is being asked. And there is four types of reasoning models, which is the deductive reasoning model, which pretty much just gives conclusions based on general rules. This is a typo, so just ignore that. The second one is an inductive reasoning model, which is just a model that generalizes based on the specific observations or data that it is given. The third one is the abductive reasoning, which infers best possible explanation for a set of observations. And the fourth one is the probabilistic reasoning model, which solves problems efficiently based on the rules that it is given. So just pretty much just finds an efficient way to solve the output while making the rules efficient. So the first reasoning model that I want to talk about is the inductive reasoning and its applications. So pretty much what the inductive reasoning model is, it pretty much just generalizes or makes predictions based on the observations or data to make conclusions. It also works by identifying patterns or trends within the given data. So right here you can see there is the input, which could be the observations, examples, or data that you do insert. And then the reasoning process for this model is that it analyzes the given data and identifies patterns, and the output it pretty much just generalizes the conclusions or predictions that are more likely to be true in similar situations. And this model is able to solve complex logic puzzles, such as the Monty Hall problem or any other complex puzzle. It will give kind of like a step-by-step uh, process, I guess, to its thinking process to show you how it was actually able to solve the puzzle. The second model that I want to talk about is the abductive reasoning. It pretty much just infers a set of observations or incomplete information, and it explains what's observed without certainty. So, pretty much with all models, they pretty much just won't say no or won't say that they're not sure when you're asking the model something that it probably might not know or is not familiar with. It will 100% not say that it doesn't know, it is uncertain. It would most likely give an answer with full confidence, even though it might not be true. So just be aware of that. And with this model, it actually discusses real world applications such as how AI can learn from data such as pattern recognition or machine learning. And with this model, it could recognize the trend in the data sets and possibly make future predictions with values based on a series of patterns. So an example of this could be like stock market trends, or like maybe like with inflation, you want to see how the prices might change with some items. I'm pretty much just gonna give an example for all of these models, so don't worry about that. The third one is the deductive reasoning, which is pretty much in charge of the logical problem solving. So with this type of model, it pretty much just gives logical reasoning where conclusions are based from facts and conclusions that are true if the premises are true. So this pretty much just explains its use in diagnostic systems, hypothesis generation, and decision making. And it can be used to solve medical diagnosis problems such as being able to identify if a model might have a flu or cold based on the description you give. So depending whether what you tell it, whether you have a fever, your head hurts, headache, stomach ache, it will give a final prediction based on what you're telling it to. So this pretty much just infers that if the inputs that you're giving are actually true, and right here says universally accepted facts, that means the output will be 100% true if the premises are true. So the output would be a conclusion that is guaranteed to be true, provided that the premises are true. The other reasoning model is the probabilistic model, which is what deals with uncertainty. So it is pretty much just a type of reasoning that deals with uncertainty by using probability theory to make decision or predictions. It highlights its use in logical puzzles and structured reasoning tasks, and it can also solve multi-step logic puzzles such as Sudoku puzzles, where the model is actually using deductive steps to be able to determine missing information. So whether it's untrue what's to come next, it will determine a way to be able to determine what is missing or what is needed to have that information. And the input could be observations or evidence that may be uncertain. The reasoning process with this is that it computes probability of different outcomes based on prior knowledge and current evidence that is given. And the output of the model would be a probability distribution that quantifies the likelihood of different possible outcomes. And so, like I was saying before, I will be showing some problems in where the models will be able to solve some problems depending on what their uses are. So, like the reasoning model, it tends to the reasoning models in general tend to give like a detailed explanation of to how it solves any problem that is given, or with abductive reasoning, it will based on what you give it, like the description of your medical diagnosis, it will give an output saying whether you have a flu, um, a fever, any other possible sickness, it might give it based on the description you give it. So yeah, I'm gonna show examples, but I'm also gonna show some failed problems that it might fail based on what you give it for the input. So what I mean by this is that, like I was saying before, some data or some straightforward questions that you do tend to ask it, there's a possibility that the model might just give a way more complex answer than is needed. So if you're asking it, like right here, the inductive reasoning, I've seen many apples and they are all red. What color is the next apple I will see? Maybe the model might say the next one will be red, or maybe the next time you ask it might say the next apple you will see is blue, and it might give its reasoning and why that might be true, even though in reality it's just, well, there is no blue apples, so it is completely wrong. So yeah, let me show you. Um, all right, let's see. Let's go to ChatGPT. This is ChatGPT is you could say an example of a reasoning model due to the fact that of all the things that it does have stored into it. So yeah, so let's say solve problems with the reasoning models. Let's ask it how to solve. Let's see, can you give me your thought process of how you can solve the Monty Hall problem? So as you can see, it is giving it in a detailed way, based on the problem. So it gives you the thought process, it gives you the steps, for the basic setup of the problem. So it gives it you in a structured form. It gives you the thought process, which is the probability, its actions, the strategy, and its conclusion, right? So all of this is in a structured form and it is detailed when it comes to solving problems. So let's try asking it, can you predict the future um values for Nvidia's, I believe it's like this, stock market. Um Base investors, however, it can few approaches. So although it can't really predict it right away, I mean it does give some tools or approaches that you could do, which is the fundamental analysis, technical machine learning. You could use machine learning for that. Uh, news analysts. So I'm not really an expert when it comes to stock market values or its market in general. So I can't really say if this will work 100% or how efficient these are. But yeah, these are some things it will give. Um, let's see, let's go out with the other one. The other one is patient has a fever, so let's just copy in this one. Let's see what it says. Technically, it should say that the patient does have a cold or flu. So let's see. But as you can see, oh, well, it says right here, like flu. It does have a flu. COVID-19. Well, I guess it does give well, it actually gives a lot of possibilities. But as you can see, based on the description you give, I didn't really give a detailed description, so it does tend to give you more options for what it might be. So that is partially my fault. But if you were to be more detailed, saying that your throat hurts, your eyes are watery, it will 100% come to an exact conclusion based on what you're giving it, right? So right here it's giving well six other possibilities, five other possibilities, but that is due to uh the input that I gave, which isn't detailed at all. And then we could just give it solve the Sudoku puzzle. How can you solve the Sudoku puzzle with the missing information that is still needed? So right here, you're asking it how can it solve the Sudoku puzzle, even though we are missing information. So right here, it is giving it the steps that we could follow or that this ChatGPT does tend to follow. So it gives you understand the rules, start with easy numbers, look for naked pairs, naked triples, use pencil and technique, applying, stay patient. So it does tend to give you examples and start process. So that's pretty cool. That's something good to know. Whether you are trying to solve some complex puzzles, and let's give it some possible failed problems that it might fail. So with basic syllogism, let's see. So all dogs are animals and all animals have four legs. How many legs does a dog have? So technically it should say four, but let's see what it says. Yeah, four legs. Sometimes it might just give a way more complex answer. So let's do with the inductive reasoning. Um, whether saying that you've seen many apples. Oh, sorry. Uh, yeah, you see. So it does say that the next apple you could see could be red, green, yellow, or any other color. I mean, this technically could partially be true, but the main one we wanted to see was just red, since most apples tend to be red, although there is some green apples, so that is true. And this one, the abductive reasoning, it could give a complex answer, um, by saying that it is uh, something else besides just being the switch being turned on and off. So let's see. Look, so this is what we want. But it is saying over here it is just a power outage, electrical issues, the light fixtures malfunctioning. So this is pretty much what we don't want. Even though it is something straightforward, which is pretty much just the light switch being turned off, it does tend to give other possible outcomes. And then yeah, let's see with this, with the probabilistic reasoning. Oh, okay, so it isn't that complex. But yeah, you do get my point when it comes to this. It could give some straightforward answers or some complex answers. But yeah, this should be the video and this should conclude everything for this week. And yeah, have a good day.